everybody, and welcome back to another one of our lessons on anatomy and physiology. So we're getting towards the end now. You've done really well to keep going to this point. We've just got one more topic after today, and today's lesson is going to be the endocrine system. So when we think about the endocrine system, I want you to think about it in tandem with the nervous system, because the two systems work very closely together. So we'll see how that happens. So here we go. So by the end of today, make sure you've got a nice cup of coffee or something to drink, and that will help you to be able to describe the structure of the endocrine system, to identify the major glands that are involved in the endocrine system, and to be able to tell me about the function of those key hormones that are secreted by the glands. And also we're going to look at the hormonal responses to training and to overtraining. Don't forget, you can also have a look in your YMCA Anatomy and Physiology manual as well to help with this. So there's some more information in there, and that'll be a good revision tool. So off we go. So what is the endocrine system? Well, it's a system that's got a number of ductless glands in it that produce and secrete hormones. And it's important to realize that the hormones that are secreted can have an action on a part of the body that's a long way from where they're actually secreted. There's one gland that's known as the master gland, and that's the hypothalamus, and that has sort of control over a number of the other endocrine glands in the body. For example, when blood sugar levels are out of kilter, that will be recognized in the hypothalamus, picked up by that. And the hypothalamus will then send messages to the pancreas that releases the hormones insulin and glucagon to adapt to bring those blood sugar levels back to normal. So that's just an example of how the hypothalamus is a sort of a master controller gland. So I mentioned before that it works very much in tandem with the nervous system. So we learned from our last lesson that when the central nervous system receives information, it's got the sensory nerves that come into the central nervous system that carry information about the internal and external environment. All these messages are then translated within the central nervous system, and then an action will happen. Now that might either be as the central nervous system sending messages down efferent nerves in order to stimulate a quick direct response, or it may send a message to an endocrine gland telling it to release a hormone. Now, the hormone responses are slower, but a really important method of maintaining homeostasis, that internal state. So those two systems, the endocrine system and the nervous system, work very much in tandem to achieve regulation of our homeostasis. And this regulation through the endocrine system happens via feedback loops. And there are two kinds of feedback loops, both positive and negative. The negative feedback loops are actually far more common than the positive feedback loops, and there are a number of examples that we can see within the body. And so one example is something I mentioned earlier about blood sugar levels. So when the body detects that there's a change in our blood sugar levels, the pancreas is then stimulated to secrete either insulin if the blood sugar levels are too high, or glucagon if the blood sugar levels are too low. So it brings it back to a normal state. And another example is a parathyroid gland, which secretes parathyroid hormone. And this is stimulated when there's a change in blood calcium levels, normally when blood calcium levels are too low. And the parathyroid hormone then has the effect of releasing more calcium into the blood. So those are our negative feedback loops, the more common ways of maintaining homeostasis via the endocrine system. There are some positive feedback loops. So the others were negative. These are positive. These are less common. Okay, so rather than the body detecting a change and then an effect happening to bring it back to normal, for example, if the body is too cold or too hot, then it needs to bring it back to normal. This is different. This is where a change is detected, and that change actually activates responses that speed up that change even more, so take it further away from the normal, as it were. And the main example of this is the action of estrogen that happens during the female menstrual cycle. So the ovaries release the estrogen, and other endocrine glands can detect that estrogen is released. They secrete hormones that have the ultimate effect of further increasing estrogen levels. So this is an example of a positive feedback loop. Here's our first image of where the glands are in the body. Now, you can see at the top, we've got our pituitary gland. That's also pretty much the site of the hypothalamus. Another gland that I think they do ask questions about in the exams is the pineal gland, which is also located in the brain. And this is a gland that secretes melatonin, which controls your sleep cycles. So actually, the brain, it shows a pituitary gland, but that's also almost the same site as the hypothalamus. And then we'll see later where the pineal gland is. So those are our head ones. Then in our neck, we've got our thyroid and our parathyroid gland, our adrenal glands there that are sitting just on top of the kidney. We've got our pancreas, which is an organ found within our abdominal cavity. And then we've got ovaries and testes that are obviously the male and female sort of glands that produce hormones. So, deep breath. Let's have a little look at our hormone summary. So I mentioned that the hypothalamus is by the pituitary gland. So they're pretty much sitting together at the base of the brain. And the important one to remember for the pituitary is that it secretes growth hormone. So obviously younger people who are growing will have higher levels of growth hormone than adults. And the actions of the growth hormone, it's going to increase your fat metabolism, it's going to increase glucose levels, your synthesis of glycogen, all these things that we need to be able to grow, promoting growth in young people, and also promotes muscle mass. So that's your pituitary in the brain with growth hormone, and those are some of the actions there. Okay, I do feel a little bit like I'm saying Cluedo, pituitary at the base of the brain with the growth hormone. Okay, the next one we have is the adrenal glands. Now they're the ones, if I go back up, they're the ones that are sitting actually on top of the kidneys. Okay, so adrenals sit on top of the kidney, and the sound of it, adrenal, sounds a bit like adrenaline. So remember that. They secrete adrenaline and noradrenaline. And the combined name for those two are the catecholamines. Catecholamines, all these names. Now, don't forget, and I think I mentioned it in the nervous system one, that these can also be called epinephrine and norepinephrine. I don't know why, but those are the different names of adrenaline and noradrenaline. So these have the effect of stimulating the sympathetic nervous system and all the effects that we learnt about. That's speeding up of heart rate, of breathing, of diverting the blood to the muscles rather than the digestive system. So that's your fight or flight system, the adrenals. Now, it's actually the core, the medulla part, which is the middle part of your adrenals that secretes the catecholamines. But the cortex, the outside part of the adrenals, does a different job. And that stimulates, that produces corticosteroid hormones, predominantly the hormone cortisol. So cortisol is something that's produced in response to stress. And we need a certain level of cortisol, but too much cortisol begins to cause problems and it can impact our immune responses. So corticosteroids generally have an impact on our immune system and regulate stress, but we have to remember that cortisol in excess is not good. So our thyroid gland, remember we found that in our neck. Let me just go back to the picture there. So that's our thyroid with the parathyroid tucked behind, and that produces thyroxine. So the names of the glands gives you an idea which hormones they produce. So in thyroxine, its role is the sort of the control of metabolism. So it generally increases, it does some of the similar things to the growth hormone, to be honest. It increases fat metabolism, glycogen synthesis, again, increases blood glucose level and does promote growth as well. So there are some similarities there, but it's very much about the control of metabolism, thyroid and thyroxine. So here's our second picture that I've put in just to show you a little bit more detail now. So you can see here how the hypothalamus is next to the pituitary and your pineal is more to the posterior part of the brain. Again, you can see your thyroid and parathyroid. Don't worry about your thymus. Dropping down, you can see your pancreas a little bit more clearly, those adrenal glands sitting on top of your kidneys, your ovaries and the testes. So carrying on with our chart, we've got our parathyroid sitting behind the thyroid and it produces parathyroid hormone, and this controls calcium levels. Now, if you remember from previous talks, we've talked how important the calcium levels are in maintaining your muscle contraction. Remember, you've got to have calcium in order to be able to free up those binding sites for the actin and myosin to work and for that transmission of nerve impulses as well. So calcium's really important. If calcium levels drop too low, then actually the body can end up leaching it from the bones. And obviously that's not going to be a good thing long term. So we need to make sure that there's sufficient calcium in the diet, that we don't want to get it at the expense of bone mineral density. So next one, pancreas. So our pancreas is near our stomach. And actually it has kind of like a dual role. So it is a digestive gland, the pancreas, and it secretes lots of pancreatic enzymes that help to break down fats, carbs and proteins. But the function we're looking at here is its endocrine gland function. And it produces the hormones insulin and glucagon. So insulin helps to reduce blood sugar levels because it promotes the uptake of glucose by the cells and also the changing glucose into glycogen, all these Gs, that's stored in the liver and in the muscles. So it brings the glucose out of the blood system, out of the bloodstream. Whereas glucagon, when blood sugar levels are too low, glucagon is released and that converts the glycogen back to glucose and increases the blood sugar levels. So that's our pancreas that lies close to our stomach. Descending down, we have our ovaries first, which are found within our pelvic region, and these produce the hormones estrogen and progesterone. And if you remember, estrogen was one of the ones that had the positive feedback loop, that once some is released, more is released. So that's an example of the positive feedback loop. And it has the effect of promoting feminization. And that's things like breasts, decreased body hair, and increased body fat. And then finally, we're looking at the testes, which are actually situated, as you know, outside the male pelvic region. And they secrete the really powerful hormone testosterone. And this is a powerful anabolic hormone which promotes all the characteristics of masculinity. And examples of that are your increased muscle size, increased body hair, decreased body fat, and also increased red blood cell count. Okay, so those are the main hormones and glands that you need to know about. Now let's look at why are we learning this? Why is it important? And it's important because the effects that exercise has on the endocrine system. So there are a number of effects, and it's actually really good to read them in your manuals because they have quite a lot of information there if you can get hold of those. But primarily, you've got, if you do quite high training, you're going to get some increases in testosterone levels, and there are small levels of testosterone in females as well, and growth hormone as a result of heavy resistance training. So that's some increases in those two hormones. When you exercise, you get improved insulin sensitivity. So that means that your blood sugar controls are improved. So for people with type 2 diabetes, exercise is going to be a really positive thing in helping them control their insulin sensitivity. And you also get an increase in something called insulin growth factor 1. You get greater amount of glucagon production as a result of exercise. So that's going to be converting your stores of glycogen into glucose. So increased levels of those. And also you do get, once you're into the realms of overtraining, then you start getting problems with impairments in adrenal and your growth hormone responses. And the other thing to remember is overtraining can have a problem with young women, especially because it can reduce your estrogen levels. If you've got very low body fat as a result of overtraining, your estrogen levels drop, which can lead to amenorrhea, so a loss of periods. And this in turn can then lead to osteoporosis. So it's really important to make sure that you're not overtraining. Thyroid conditions can need to be looked at in terms of training as well, as they can impact the ability of an individual to take part in physical activity. So do be aware if a client has any thyroid issues. And I think that those are the fundamental ones. It's understanding that obviously during training your blood glucose levels are going to drop. So you need to make sure that any clients you have who are at risk of hypoglycemia, low blood sugar, need to have sufficient forms of fast-acting carbohydrate close by. Okay, so I hope that's been helpful. I think things to be aware of. Another slide. Great, I forgot to put this one in. So things to be aware of with overtraining. So when you exercise, fundamentally causes the body stress. And this, if you put your body in a state of excess stress, this is going to increase your cortisol levels. And with too much cortisol, I'd mentioned about cortisol, one of the corticosteroids, this can have a number of negative effects. So you can have impaired cognitive performance, blood sugar imbalances, decreased bone density and muscle mass, lowered immunity, increase abdominal fat, inhibiting testosterone production. So this is specifically to do with the effects of cortisol. If when we're overtraining, we're overstressing the body. And then finally, looking at the growth hormone levels, which I'd said can rise with intense exercise, and just being aware that excessive growth hormone can actually inhibit protein synthesis. So there's a little romp through our endocrine system. So hopefully now you can describe the structure of the endocrine system, what glands there are, identify those, and look at the functions, be able to identify the functions of the key hormones in the body secreted by the endocrine glands, and be able to describe some of the hormonal responses to training and overtraining. So the only thing I'd add to this, as far as I'm aware, do learn that table, but don't forget that other little gland called the pineal gland, which secretes melatonin, which has an impact on your sleep cycles. That's the only one that I'm aware that they have asked questions on in the past. It doesn't seem to be involved in this particular presentation. Okay, well, I hope that's been helpful. Do go over anything, again, that you're not sure about. Come and ask me and go and have a go at the quiz. Okay, well done for getting to the end, and I'll see you again next time.